Okay, so for lab 13, experiment 1, here's my setup. Hopefully you can see that. Here's a close-up of the cup I used with all the stuff in it. And then for the post-lab questions, it asks, one second. It says, what did you... Oh, sorry, sketch and label what the arrangement of objects and liquids were in the beaker. So I did a little sketch of that, and here are all my post-lab questions, which I'll upload to Foxtail later. But, and then the second question says, rank the liquids and solids in order of least to most dense and use your results to explain your reasoning. So I said the cooking oil was the least dense, the water was the second most dense, and then the corn syrup was the most dense, because that's kind of how they were in order. So the cooking oil, water, and then corn syrup. And then the third question asks which of the solid materials used in this experiment would make the best boat and why. I said the cork would make the best boat material because it is the least dense and most buoyant. As you can see, it's floating right there on top of the cooking oil. And the fourth question says, would it be easier to design a boat in a world with oceans of maple syrup than oceans of salt water? And what property of maple syrup might prevent boats from traveling in it very effectively compared with water? And I said that it would be easier to design a boat in a world with oceans of maple syrup because maple syrup is super dense in contrast to the material that boats are made out of, so boats would float more easily because they're a lot less dense than maple syrup. However, it might make traveling in it less effective compared to water because of its density, so it would be really viscous and hard to travel through, and you wouldn't be able to get through it very fast because it is so dense. And then in the second lab, so I had a little difficulty with this because, or my lab assistant, I had a little difficulty with this because the slinky got so tangled, but I tried to work through it anyway. Here are my tables, which I will obviously upload to Foxtail later. And for these post-lab questions, it asks, did the wave seem to go faster or slower when you tested a variety of amplitudes and frequency? And so I said the wave seemed to go faster with a more tense slinky, and then the wave seemed to be slower with a less tense slinky. So when it was just loose, it would take a longer time to reach equilibrium. And then the second question asks, what did you notice about the speed of the longitudinal waves compared to the transverse waves, and why do you think this is? I said the longitudinal, which is the one where you grab and release, are faster because the one cycle is a reaction to the compression, so when you let it go, it compresses super quickly. And then transverse are slower because the wavelength takes longer to reach equilibrium, so it's kind of snaking to reach equilibrium and it doesn't reach as fast. And then question 3 says use data from table 1 and 2 to calculate the average time it took for the wave to travel down and back. Use this time to calculate the average speed for the traveling wave on Slinky for both situations. And so I got 1.5 seconds average for the first, for the relaxed Slinky, so that was like the average time I got. And then the second average time I got was 0.69 seconds, so a lot quicker than the relaxed Slinky. And then I filled out the table, which I think will be easier explained once I upload it to Foxtail. You can look at it because it's a little bit harder to explain here in the video, so I'll just upload that. Yeah, so that was about it.